Ladies and gentlemen, good morning, good afternoon, and maybe even good evening, depending on where you are joining us from today. And thank you very much for joining us for this roundtable on modernizing commercial USV operations. My name, as you can see on the screen, is Alix Valenti. I am a defense journalist, and I have the pleasure of moderating the roundtable today. Now, as you can imagine, as a defense journalist who's primarily been writing about Navy and naval technologies, I've done my fair share of research on USVs, unmanned surface vehicles, and well, I have found them to be, especially in the last few years, and I have found them to be maritime autonomy to be fascinating, complex, and sometimes, quite frankly, a little bit of a tricky concept. It's a technological challenge, a very, very fascinating one for engineers who have been working on it for the last few years, actually for the last decades, as we will discuss. It is also an operational promise across many different fields. It's a headline grabber for people like me who are journalists, and it is also a bit of a catch-all. But what I have found across all of this is that we very often fail to understand or grasp that autonomy is not necessarily just about the platform itself, but it is about all of the systems that enable this autonomy. Because without the sonars, without the autonomous systems, without the processors, well, there's no autonomy. So this is effectively what we are here to discuss with you today. We will go from the promises of USVs and in commercial operations, and also the current state of the USV sector, all the way to the challenges of human resources, trust, safety, and regulatory environments for these systems to operate in and even be trialed, because that can also be its challenge on its own. And we will try to give you as complete a 360 picture as we can on USV opportunities and challenges. Now, joining me in this conversation today is a truly international panel. We have Matthew Zimmerman, CEO of FarSounder, who is joining us from the US. We have Simon Adams, director of the USV Group, who is joining us from the UK. And finally, last but certainly not least, Olivier Moisan, the DRIX USV Operations Managers, who is joining us from France. And I am personally based in Italy at the moment. Just a bit of a heads up, the heat wave that has been hitting Europe at the moment is playing tricks on my internet connection. So hopefully I will not have any issues. But if I do disappear, don't worry, I have backups. I will be back very quickly. And one last little bit of housekeeping rule. We have a little column on the right-hand side where you can post your questions. Please feel free to post them as the conversations move along. We will keep an eye out for those, and I will insert them in our conversation as the themes come along and as I see fit. And hopefully we will get to answer them all. Hopefully you will have plenty of them. If we do not, we'll keep track and we'll try to answer them later on. Now, without further ado, I would like to kickstart this conversation today with probably the most complicated question I can ask today, which is, what do we mean by autonomy? I have my own opinions, but you are not here to talk about, to hear me talk. So I will give the floor to perhaps Matthew Zimmerman, if you would like to kick the conversation off.
Thank you, Alix, for the introduction. Yeah, I think autonomy is a very wide term that can really cover a lot of ground. Obviously, the holy grail is fully autonomous systems that can deduce what you imagine you'd like to happen, and those things just happen. Interacting with other autonomous systems, interacting with the environment, interacting with other people. And I think that is a long way off if we even ever get there. But I think there's a lot of small steps that exist today that can be used and add value. I think there are a lot of slightly larger steps as you put more of these blocks together coming down the road. And there's already lots of ways where autonomy can be quite in depth under limited conditions. So I'm excited to chat about how all of those things have been happening, are currently happening, and what will be happening in the near future.
Olivier or Simon, would you like to? Simon, yes.
Yeah, sure. It's a great question and really well introduced. And I think it ties back into some of your elements of introduction, i.e. Autonomy, as we know it, can be tricky. And it really is. And I think that a lot of that has come about from this term autonomy, maybe before we quite got there. I think a lot of us that entered the sector quite early on, I think to some extent we all underestimated it, maybe a little bit, and then things got tricky. So we see it across the board. We see it in social media, we see it in marketing, we see this word autonomy, but quite often that's not entirely the case. It is the Holy Grail, as Matthew says, and I think it is what we're striving towards, but I believe we've got a little bit of a way to go yet.
So you both mentioned, and I will give the floor to Olivier in a second, and maybe he will answer my question, but you've both mentioned that we're striving towards something, and you've both mentioned the Holy Grail. But I was wondering if you could give us a little bit more information on what it is that we're striving towards. What is that Holy Grail?
Absolutely. Well, first of all, I think autonomy is, at whatever level it is, it's being able to offload something that we are doing actively, maybe that's manually, or maybe that's emotionally or intellectually, but offloading something that we as the person, the human operator, into something that can be controlled through the autonomy systems. And when you think about operations at sea, whether that's for defense or commercial, whether that's surveying, whether that's shipping, whether that's security, whether that's search and rescue, there are a ton of steps and tasks and activities that need to be done in order to achieve your application, goal, mission successfully. So in the simplest sense, autonomy could be, I want to get from where I am here today to this port at some time in the future. What's the best way to get there? The manual way was looking at whatever charts you had, trying to connect that with tide and weather inputs, kind of compile that and integrate that in your mind and do some calculations and try to estimate what's the best route. There are a lot of tools, and I'm certain that they're not 100% effective in 100% conditions 100% of the time, but there are a lot of tools that offload a lot of that work. So that's one building block that can be used and run autonomously. You can say, I'm here, I want to get there, plot me the route with these level of considerations: safety, speed, fuel efficiencies. How you operate the vessel to get there is obviously another level of autonomy. And I think there's really three parts to that equation. One is what is the perception available? So knowing what's around you above the water, obviously FarSounder, knowing what's around you below the water. Two is, what are the other things around you doing? So you're not just sensing the world, but predicting what they're doing. Think about the ship captain who sees traffic up ahead. Is that sailboat going to tack? Are they going to stay on their current course? Here's a vessel that is coming at me on the wrong side of the shipping lanes. Are they going to turn across my bow? So this prediction level. And then there is the implementation of that. So adjusting the engines, turning the wheel, setting the sail. So the manual operations of the vessel. All those things individually or together could be connected.
Thank you, Matt. I'll add a few things related to obviously the USV topic. I believe there is sometimes a misconception about autonomy, and people might tend to confuse that, autonomy is being uncrewed, where I think there are actually several concepts. A vessel can be uncrewed and be highly autonomous, without being highly autonomous. And on the other side, a crewed vessel can actually already use significant amount of autonomous functionality. So I think the real question is not whether humans are removed from the system, but our tasks are allocated between human and machines. So I think the really important part is human remains essential in these tasks, even though we talk about autonomy. And the real point is, how can you manage to bring that efficiency that we call autonomy by integrating both human and machine in the loop?
Yes, thank you, Olivier, and I think this really touches in the heart of the matter, because as I often like to tell people, I've been told all sorts of stories when I go to stands in shows, in trade shows, where like, oh, this system is autonomous, and then this means a whole variety of different things, and sometimes it turns out it's only, so to speak, remotely piloted, and sometimes there actually is no crew. Sometimes we mean something different. So yeah, there's a whole collection of meanings for autonomy. And so what I'm wondering at this point is, I'm used to the defense domain. I know more or less where we're at when it comes to autonomy, but I would like to hear from all of you, and perhaps I'll revert back to Simon, as I also had a question for him earlier on about the Holy Grail. But where are we at the moment in the commercial sector? What is autonomy for the commercial sector today?
Yeah, thanks, Alix. It's varied. It started out, if we compare it to the defense space, I think the commercial sector took a lot of the stardom. It became a lot more well known in the commercial space several years ago, even though the mine countermeasure work had been going on for some time in the MOD space already. So the commercial sector kind of got a lot of the stardom a few years ago, and now it's starting to even out a bit. However, saying that, what are the actual successes? What are we really seeing that's doing meaningful work out there? Well, I mean, obviously we've got Exail. I have to mention those guys. They're here with us. They've built more than 30 units, I think, for their DRIX, and a couple of the big ones now, the 16 meters. So we're seeing huge gains in that area, and the majority of those vessels, correct me if I'm wrong, Olivier, have actually been in the commercial sector. But also at the slightly larger end of the scale, if we look at what we're getting out of Norway, there are a couple of larger vessels around the 24-meter mark. So the Reach Remote just made a port call, completely autonomous, or uncrewed, should I say, port call. So that's a first, and it's happened this year. So the USVs being applied are slowly getting bigger, and the capabilities are getting better, but it hasn't been without some pain along the way. It's been a hard road. There's been a lot of reinvention of some of the more traditional elements, I think. So we talked about charting and navigation. A lot of these USV providers are creating from scratch entirely new interfaces, but we already have really good navigation systems on ships. Surely we can do something with those, right? Well, you would think so, but it's not happening. So we've had to start from quite far back in terms of our capabilities and have to build in the autonomous or remote capabilities from the beginning. So yeah, I think we've made great grounds, and we're only really starting to see meaningful commercial output. Part of it is due to true capability, but another part of it, and a massive part, is the regulation. So the regulatory codes. We're only just seeing that really start to settle, and it's still very uncertain in most regions.
I think, Simon, you touched on a couple of interesting things. One is the comparison between autonomy in the commercial sector and the defense sector. And I know today we're focusing on commercial, but I do think at some point we should talk a little bit about what those distinctions are, because I think that's what is happening in the defense sector is based on what started in the commercial sector, and what will be in the commercial sector is going to roll up a lot of the things that are happening now in the defense space. So I think that's interesting for the future. But getting back to your point of what's happening today, I think there's a lot of incredible things. And I'll let Olivier talk about what's happening at Exail. But for example, they have a survey area. And if you know anything about down-looking multi-beam surveys, when the depth below you is deeper than your coverage width is wider, and when it's shallower, your coverage width is more narrow. So if you have like a subsea canyon, you're going to have deeper and shallower areas. And if you want full coverage, then you need to manually adjust your routes of the vessel as your coverage widths vary. You can do that manually. That requires a lot of attention, prone to error. It requires people in a relatively stressful environment, and Exail's real-time, not just route planning, but updating the route based on the real data. Like, that's autonomy taking a big block of tasks at hand. So today it's helping to improve productivity, and I think it's exciting.
Yeah, I think the very interesting thing is the fact that, you know, we can see USV deployed on many different operations now, hydrography and geophysical surveys, obviously offshore energy. Alix, you mentioned the defense market. The defense market is picking up quite fast in security and surveillance, for example, scientific research as well. And the really interesting thing as well is that people are seeing now the USV platform has the ability to offer options. You know, you can do USV only, you can do a combination of USV and crewed vessel. You can do port-to-port operation. You can deploy them from a motorboat. You can control them from a shore station and so on. And all of these are actually providing a lot of options that helps obviously the success of the USVs. Now, of course, Simon is right. You know, we were not too many 10 years ago, and the path was quite hard, you know, starting 10 years ago. There is the regulation question. Of course, we are more and more out there now, companies. So obviously there's a need for rules, and there is a need for a right balance in between the rules that will obviously define, you know, rules for the USV use, but also you need to avoid, you know, killing the development of these technologies. So it's a difficult. And then there is always the question of trust. You know, are everyone trusting the USV solution at the moment? I think the USV is still a relatively new market, although some of us were here 10 years ago. And trust is usually built through operational experience, you know, rather than marketing claims. So we still need to be able to demonstrate that the USV is now a reliable, scalable solution for operations.
Simon, you wanted to add something?
I completely agree with Olivier, and I think, you know, if we take the view of a business, a company that wants to take a USV and integrate it into its existing operations, that carries its own swath of challenges as well as the regulatory. I mean, if you're going to commercialize a USV, how are you going to then go and tender that to a project? How are you going to cost it? How are your tendering engineers and your accounts teams and your HR teams going to adjust what they know traditionally to this new technology and development? So actually, it's not just the technology and the levels of autonomy and the regulation, it's the crewing, the staffing, and integrating it into the business. And that's a huge challenge in itself. And a lot of us have misinterpreted or underestimated that in the past too. And yeah, we've learned the hard way, but we're getting better at it, I think, as an industry, and we are starting to see it more and more. So it is getting there, and it's kind of following step now with regulation, which was lagging way behind.
Matt, I saw that you wanted to add something, but before we move in, because I can see that we're very quickly going into integrating and human resources and trust. But before that, you have all mentioned regulatory environments. And this is something I wanted to go back to, because I'm thinking, if I am thinking of getting USVs, if I'm watching this this talk right now and I'm thinking USVs can really help my operations, what does it mean that the regulatory environment can be a challenge? What do you all mean by this? And what are the steps? Because my understanding, at least at the moment, and at least from what I've seen in the defense world, is that each country has its own regulations on how you can test them, where you can operate them. And of course, we also have the IMO regulations for safety of navigation. So what does this regulatory challenge look like, and where are we right now?
Well, I think that's an important topic to cover. And you rightly pointed out that when you're developing and testing, there are lots of regulations. And I think in the commercial sector, those are driven very much from the perspective of, we're doing something today with a crewed vessel or a fully crewed vessel. What are the safety and regulatory requirements for that vessel? And now as you work towards a uncrewed or a less crewed, more minimally crewed vessel, you need to maintain the same safety and the same operational capabilities during your testing. And I agree with that. I think that's important. From the defense sector, we are seeing, and we will continue to see, that in active conflicts, those that are using these uncrewed systems as tools are not going to follow their rules. They're going to do whatever they think is necessary to achieve that mission. And whether you agree with that or don't agree with that, my opinion doesn't really matter there. It is going to happen. And there will be lessons learned that will be able to be brought back into the commercial sector. I was on a panel at the World Maritime Forum in Copenhagen earlier this year, talking about these topics specifically in the commercial shipping world. So very different vessels than the Exail Drix platforms. And that is a very slow moving, conservative environment. Also not with a lot of R&D funding in that area. It's very much been we've always done it this way, so why would we change? So there's that type of pressure as well.
Yeah, just to add a few things. You mentioned it, Alix. One of the main problem is the fact that almost every country has its own regulations. To take the example of France, I'll leave the UK to Simon. I think he has a few things to say, but no, I mean, for a company that is trying to use USVs in different countries, it's sometimes difficult to keep up with the rules that are being set up in these countries. So that's one of the first thing. And although it seems that there's starting to be a common approach among the different countries, for Europe, for example, they sometimes all have a different approach on how to address the regulation on USV. So you've got companies that just decided to forbid access to waters for USVs, and others. And I'll take the example of France, that I think was quite of an interesting path, was that really start with experimentation and allow companies that were developing USVs to put them in the water and to test them, to be able to assess actually the reliability of these systems and so on. And it helped us. I'll take the example of Exail with the Drix to really keep on building the platform, on improving reliability and so on. And once again, we started quite a while ago, so it was very interesting to be at a very early stage, engaging discussion with France regulation for to be able to test this system in the water.
Yeah, I think Europe has all taken their own stance from what was generically some guidance that I think came down from the IMO. There was some European guidance issued, and now individual countries have taken their own view on that and got a slight variant of a similar thing. The key word I think that you mentioned there, Olivier, was experimentation and trials. And today, even if we as commercial operators go to a flag state and want to carry out a commercial operation, it's still technically known as a trial or experimentation. The UK is slightly different, where there is actually a legally enforced code that's aimed at remotely operated uncrewed vessels. Note the term remotely operated, not autonomous. So it's a regulation to enable remote operation of uncrewed vessels. So that only works less than 24 meters. And then we've got the IMO MAS code that's been adopted, still in draft at the moment, not available for public domain just yet. And that will cover above 24 meters. So I think the majority of the USVs are sitting in that less than 24. And generally the European codes still are taking their standards from the larger codes that are suitable for larger vessels. So that means much of Europe is still in what I would say is a slightly disproportionate regulatory situation where larger vessel codes are being applied to smaller vessels. And that was what was happening in the UK for quite some time until the Workboat Code came in with its dedicated annex. So now in the UK, although it's been painful, there is a pathway. And subsequently, there have been further pathways that let the smaller USVs, less than 4.5 meters, less than 2.5 meters, to have slightly lesser regulations still. But for those in Europe, it's still a bit tricky. And globally, it's still really a case-by-case basis, is my understanding.
I think your description of separating into different size vessel tiers is quite interesting. And that correlates quite well with the USV programs that we've been part of at FarSounder. I've seen sort of the 7 meters in length and below as one group of vehicles, another group around the 12, 13, 14 meters in length, and then much larger ones, with the largest one we've been deployed on so far being about 60 meters in length. And I think that there's another part of the equation for the size, and that is the operational paces and the maintenance that are required. Olivier, I was at your La Ciotat facility earlier this year, had a fantastic tour, and learned a lot about the endurance, which is pretty impressive for your vehicles. I have a pretty good relationship with University of New Hampshire, who's operating one of your vehicles. Again, some very impressive durations. But when you're done with your deployment, your vehicle comes back for some sort of service refurbishment. It's taken offline to do those things. If we look at the commercial shipping sector, cargo ships, they're doing the majority of their maintenance while they're underway. They're painting the deck, they're lubricating the winches and the hoists, they are changing the oil on the engines. And to talk to a commercial shipping operator and say, hey, we're going to get you a fully uncrewed vessel, and every 3 months you need to take it out of service for a month or 6 weeks or whatever that period is, they would laugh at you as like, we could never do that. So there's going to be different operational paces and maintenance needs depending on the size as well. Certainly for a 60-meter vessel, you probably can't afford to have one spare for every 2 in the field that's going to rotate out during maintenance. But for the 3-meter USV, you probably can have 3 on the shelf that you're just going to swap out while you do the maintenance. So, getting back to Simon's comment about operational and how it fits into the bigger commercial picture, I think that's also an interesting part of the conversation.
Matthew, I think you made a really good point there about how these maintenance programs work. And if we tie it back a little bit to Alex's earlier question about what's happened out there, what's really succeeding, if we look at some of the more successful operators that exist in the smaller end of the category, it's companies like Exocean and Saildrone. And the things that these operators that have managed to scale have in common is that they are manufacturer-based owner-operators that have fleets. And that is the mitigation for that very problem. There aren't many companies out there that buy 1 or 2 USVs that get full uptime on them. So we're at this point, partly because of the trust, partly because of regulation, and partly for the reasons you've just described. We're seeing sort of intermittent use of USVs in the commercial sector. We're not quite seeing them getting there all the time. Whereas the owner operators, that have 3 or 4 or a fleet of 30 can afford to swap one out and put another one in field. So there's definitely a stark difference there.
Yeah, just a small comment on Simon's last sentence. I totally agree with what he just said about the manufacturer being the operator. We are doing that as well at Exail, but it's not our key business. Our key business is really to sell the USV, and that our clients are able to actually operate them on their own. And it has been a challenge. Once again, we started 10 years ago, and I think we are at a point when we manage to, and I think for companies building USVs or using USVs, it's being able to scale and to make systems that are reliable enough so that your client is able actually to put their hand on the system, and through a few trainings and some operations together, they are actually able to operate on their own. And I think that's one of the key challenges at the moment, is really the client taking the USV. Once again, we're talking about larger USVs for I would say the 1 to 3 meter range. I think we see a very important success of manufacturer for specific applications, such as small lakes and stuff like that. When you've got small USVs that obviously demonstrated reliability, but for bigger USV there is still a challenge. And I think this is the real key for manufacturers, the ability to to transfer this reliability and this knowledge to another company that will be able to fully operate the system on their own.
Thank you. And Olivier, in fact, it's perfect. You cued in my next question just perfectly, because I was going to say, and this ties back to something that you all mentioned earlier on as well, before I jumped into the regulatory landscape. But I have a feeling, and you correct me if I'm wrong, if the commercial landscape is a bit different, but in the defense domain, there's that sense, there's that misunderstanding, I should say, that, well, we have autonomous systems now, we don't need people anymore. And I have a sense, at least for now, that you still need these operators. You still need the people who do the maintenance. You still need the people who sift through the data, because there's plenty of data coming from those systems. Those that work the architecture of the whole fleet. So what does this mean in terms of, first of all, my first question would be, what does this mean in terms of how many people we need and where are we going, but also in terms of training?
I think in the commercial sector in particular, if we look even at crewed vessels, there is a pretty strong need for more people, more well-trained, skilled people to do the things we're already doing with crewed vessels. So from the commercial shipping perspective, for example, I think some of the goals they see on the maybe not near term, but at least midterm horizons are not getting rid of people on the vessel, but looking at the bridge crew. A large ship might have 8 or 12 bridge deck officers. Can you reduce that to half of them, and then have a shore station with a few people that are remotely monitoring 3 or 4 vessels? So it'd be a hybrid, remote, autonomous, crewed hybrid. So you have a person on board for those things that need to be done with a person right now, today. You can increase retention, because spending your entire life at sea for some people is great, but for many people, they don't want to do that forever. And what's going to happen after 10 years at sea, or 12 years at sea, or however long that is? Now there's an opportunity to retain that fleet knowledge, bring them to shore, be the shore remote operating center operators, assisting the lesser crewed commercial vessels. You're not getting rid of jobs, you're increasing efficiency and filling the needs of vacancies that are already there today. Similarly, for the hydrographic survey world, keeping good surveyors willing to go to sea is tough. But allowing them to do a lot of those same jobs as we get more real-time bandwidth, as we get more autonomous route vehicle driving like Exail's developing or delivering. That's another way to fill the personnel gaps and improve efficiencies without taking jobs and without losing people from the industry.
Completely agree, Matt. And a couple of things. First, your first point, there is a skills shortage in the marine sector. It's a fact. We're going to run out of people that are going to be able to go to sea or want to go to sea. It needs to be addressed. The second point, another misconception in the industry is that autonomy is going to take our jobs. No, the MAS code's coming in. All of the regulations that currently exist say you have to have an operator, a human operator supervising these systems. And what's more, they have to be mariners that understand collision regulations. So that's the way it is for the time being. So you're absolutely right. The challenge is actually, how do we get these guys ashore? How do we get these seafarers trained appropriately? But then what happens when they come ashore? Because if you know the Maritime Labour Convention, there are work time regulations that apply to men and women that work at sea. And when you take that context and you overlay it into a remote operations center, your work time hours are going to be really, really difficult, because you can do 12, 14 hours a day at sea. I mean, it's kind of normal to do a 12-hour shift offshore. If you try doing that in a small room full of computers and screens, it's just not going to work. But there are no protections available for these personnel. The studies are being carried out and there is work being done, but actually there's nothing to stop people working in your office for 18 hours if you want to. So again, there's a regulatory mismatch here, and that's going to make the transition difficult, amongst other things.
Yeah, no, I fully agree with you, Simon. I think we need more and more people to work around, the USV, around the USV. We have never hired more software engineers, technicians for maintenance, operators. It's sometimes difficult to find people. You're absolutely right, Simon. Because of the constraints sometimes of, what the maritime world is offering, and, going out offshore for 2 months, it's a quite heavy constraint. So what I think is very interesting is, like I said previously, the USV is providing new options. You want to get out there and you want to be able to operate an USV from another vessel, and well, obviously you can do that. And we've got organization like NOAA or the French hydrographic services, for example, that are planning on deploying these USVs from a motorboat. So they will still have mariners and they will still have crews and they will still have people on board with USV skills. Or you can just decide to remove these constraints and actually have operators operating USVs from shore. And so providing these options are really key, I think, for me to maintain all of these people in the USV ecosystem. And I think Matt mentioned previously, some of the features that we develop at Exail. I think it's also a really important part when we talk, about sensor fusion, about putting the human right where we need them, and so that they could have a very interesting contribution instead of, doing tasks that obviously are no longer really needed. And it's, I think, one of the other keys really, once you've built USVs, once you've built systems that are able to absorb all of these data, it's not, just to absorb this data and to create reports and so on, but you need to make intelligent system out of it. And so Matt talk about, our autoline system. It's basically once you understand the radar, once the system understands the radar, you create your obstacle avoidance system. So you create it above the water, then you integrate the FarSounder for subsea avoidance. And then you start integrating new payloads. And so you have your multi-beam system. So you're understanding actually the type of data that you're collecting. You're understanding the source. You're understanding the quality of the data. And so your system, a little bit like AI, that are building new model almost every week now, that are more and more intelligent and allow you to do more and more tasks. Well, you get this USV system that are getting more and more intelligent, that are hence getting more efficient on the operation. And once again, you keep the human where really you need, decision to be taken, and the system is actually able to do the operation on its own.
I think it's really interesting, Olivier, you talked a lot about the systems, the intelligence, the fusion, the operational. You haven't once talked about fabricating the hull. And I think to many people, maybe not even in this sector, but in the general population, when they think of USV, they think of the boat building portion of it. And I know Exail also does that, and your history comes from the boat building side of things. But I think it's pretty clear that the value in autonomy systems and USV operations, whether fully crewed, partially crewed, is the system, the integration of the perception to make the decisions, to fulfill the operational requirements. And the hull is just almost like just a particular design choice of how you put those things together. So I think that's really interesting to hear that the value points that you're talking about, Olivier, is really the fusion of the systems. So thanks for sharing that.
The hull is effectively the vessel, isn't it? For everything else. Before wrapping up, because we are getting towards the end of our chat today, but I did have one last question for Olivier, because you mentioned that it was hard to hire people, to hire the engineers that you need for all these systems and everything from the point of view of Exail. But I was thinking, going back to the point that Simon and Matt also made in terms of like training people to use these systems, is this something that Exail also does? Like when you're selling your system to a customer, do you also offer the training that goes with it?
Yeah, yes, we do. Yeah. I think it's, once again, in this challenge of transferring our knowledge to our client, basically, that is a new owner of a USV and basically start from zero. Obviously, the training is essential, and so we put together several types of training, different types of modules, depending on the platform itself. Of course, we've got a 16-meter vessel and a smaller one. Obviously, the complexity is not the same. So you need different type of people, obviously, depending on which vehicle you've acquired and you want to learn about. And it's also about the organization. We've sold USVs to big organizations, and so obviously they've got many people to train. They don't want everyone to be at the same level of experience and of knowledge on the system. You may need, what we call ROC operator, so remotely operating system operator, and you probably need technicians for maintenance, and you also need basically experts, people that will be able to troubleshoot something that could happen. So we needed to actually create this module so that we could address the different people that would have to train on our platform.
Thank you, Olivier. So back to the point that everyone was making and that I was asking the question about, it's not at all about having less people, it's about having people trained differently, doing different tasks, and hopefully much more interesting tasks. As I mentioned, we're coming close to the end of this discussion today. We did have one question, and it was a question about from the audience, and it was a question about the use of USVs in humanitarian assistance and disaster relief. I think, Simon, you said you wanted to take this on, so the floor is yours.
Yeah, in short, there's not much happening in that space, but I have thought about it, actually. There are some USVs that are engaged in personnel recovery. So there are a couple of USV providers that are now being used by people like lifeguard industries and rescuing people from offshore environments. So that's happening. There's quite a lot happening in the oil prevention space or response to oil and pollution. USVs are being used for that. But I think in terms of the humanitarian aid question, I think because seaborne vehicles are generally slow, they would be slow to respond. And I think the aerial piece is likely to have more of an immediate impact. But saying that, if Greta Thunberg is listening and wanted to provide some aid transports, she might stop getting arrested that way. So yeah, please give us a call if that's what you'd like to do. But it's a good point, and I think it's really interesting. And I think we do need to look at ways that we can leverage this tech for good as well as defense and commercial and energy markets.
And we just saw recently a Saronic vehicle picking up the downed airmen in that conflict zone, basically using an uncrewed vehicle to collect and transport people to keep more people out of that threat environment. I think we can see things with other applications that are newly becoming viable, like post natural disaster. This is now quite a while ago, but after the disaster in Haiti, we didn't bring the supplies in immediately. We had the ships right offshore, but the harbor that used to be clear, they didn't know if it was filled with debris. Well, back then we did not have autonomous systems you could send out and do a quick and dirty survey. Those systems exist now, so you can stand off with your expensive assets and put in the lower cost assets. So anywhere where there's risk for personnel or asset, I think we'll start to see deployed as tools, just like we're seeing in conflict zones and in commercial operations.
Olivier, is this something that perhaps have you been approached by any potential customers in this space or not yet?
No, it's not something that we've addressed yet. The shape of our USV actually doesn't make this type of operation very easy, but it could be something that we'd be looking in the future.
Having said that, I also think, just to add my 2 cents, seeing as I come from a development background originally, I think back to what you were saying, Matt, it can be, besides transporting people, saving people, or transporting supplies, it can also be something that goes in, and I'm going to use ISR, and people will feel badly about this because it's a military term, but it can be intelligence and reconnaissance and surveillance to see if there are debris, what the situation is, if other ships, bigger ships with all the supplies can go in. So this can also be a more immediate use for these systems without putting anyone at risk, but precisely to avoid putting any more people at risk. So that's an option. All right, well, we have covered a lot of ground, and I'm sure there will be plenty more to cover. What I am gathering from our conversation today is that we are moving along in the USV sector for the commercial sector, that regulations at the moment are still a little bit of a patchwork around the world, and especially around Europe, but we're making progress to facilitate testing and also operational testing and also operations. And the training aspect can be a bit of a tricky challenge at the moment, but we're also working on that. So it's moving along, it's moving forward. And I think the more people actually take on the challenge of having integrating USVs in their operations and in their organizations, the more we're going to have more case studies, more feedback, and the better the regulations are going to get, and the better the systems will get. Now, I want to send you a challenge, one last challenge, each and every one of you gentlemen. If in 1 minute you want to give me your last thoughts, your last words, anything that we may not have discussed, but you want our audience to take away for our conversation today. And Olivier, do you want to go first?
Yes, of course. Yeah. No, I think what we've discussed about the introduction of USV for commercial application and the way it went for the last few years shows that the industry has already proven that the USVs can perform commercial missions, and I think the next challenge is not technological capabilities but more like industrialization. Success will come when USVs are no longer viewed as innovative projects, but simply another tool, and that operators are able to use them on a daily basis to collect data in a safer way, in a more efficient way, and in a more sustainable way.
So a little bit like the arrival of the iPhone and the smartphone, like going from something amazing, I've got my emails in the palm of my hands, to I'm using this for anything.
Yeah, that's a very good comparison. Yeah.
Simon, would you like to add something in 1 minute?
1 minute, okay. Well, I'd like to say that in the years that have gone by, the last sort of 7 or 8 years, the improvements in the technology and the operations are tenfold. I mean, we didn't have Starlink. We were driving USVs around wind farms without Starlink. We were getting one frame every 4 seconds, and we were trying to carry out bathymetric surveys. It was really tough. Now, with the advent of the latest LEO comms, it's a complete change, and everything has sped up thereafter. I think the next bit I'd like to see change on would be the human in the loop, getting that seafarer appropriately trained. Quick fun fact: back in the 1950s, we used to use ponies in coal mines in the UK to drag carts of coal around. The environmentalists and the animal rights activists managed to have a law passed that gave the pit ponies work time regulations. Those work time regulations for those ponies was better than seafarers have today. So I think we have a real opportunity to update that a bit as we make this transition ashore. So I'd like to see something move in that area. Thank you.
I couldn't wait to see where you were going with that analogy, Simon. Thank you for this. And Matt, you've got the last word.
Well, maybe not the last word, but certainly a word. I really like the theme that Olivier and Simon brought up, which is using autonomy as a tool. We can increase efficiencies, productivity, and increase safety, whether that's environmental or to the operators and the crew themselves. But I think what the real important takeaway is looking at autonomy as a system. And as I said at the beginning, there are blocks in that system today that can be replaced in many cases with existing autonomy blocks that are available today. But how do we integrate that into the overall system? That depends on what is the application, what is the perception, and what is the decision-making capabilities. And as the industry gets good at one thing, they're going to take those lessons to move it to another application, another application, another application, and we'll be using that more and more. So I'm excited to see where that goes.
Absolutely. And yes, I think this is a little bit also what Olivier was saying, that we're seeing, the overall architecture, and then training people, finding the people who can work on that. And then I think it also comes down a little bit to customers being able to express their needs more clearly, and industry answering them. It has been an absolute pleasure moderating this discussion today. As I said, I think there's plenty more to discuss still, so that's an opportunity to reunite again at some point down the line. But that is it for us today. Thank you so much to the audience for joining us today, and thank you more specifically to the three of you for all your insights. And I look forward to another conversation down the line.
Thank you, Alix. Thanks, everybody. Thanks, Simon, Olivier.
Thank you, everyone.
Thank you.